So in Unit 3A, we talked about quadratics in quadratic form and how you factor those and solve those. From looking at your 7A pretest, it does not look like we need to talk specifically about just some of the basic factoring. Now I will include that in some of the problems like when we get to quadratic form, but I am going to just jump straight into what we did when we couldn't factor, which was quadratic formula. And so that's what both of these are going to work out to be. So first off, your quadratic formula, I'll just write it here in the middle in case you've forgotten it. It is back. Technically, it never left. So you do want to make sure to have a good handle on that. Anytime you're going to factor, solve a quadratic of any type with quadratic formula, whatever it is, you do need it equal to 0. So I'm going to set this equal to 0, and I'm going to put it in order from largest exponent to smallest exponent. And my personal recommendation is always, always, always try to factor. So say this is negative 30, add to 11, and try to factor because typically it is easier. Again, not for everyone, but that is just what I found. Multiply to 30 and add to 11, you may tell me, hey, that's 6 and 5, but your signs ends up not working because this needs to multiply to a negative 30. So one of them would need to be negative, and neither way ends up working. So this is not factorable, which is what tells me I have to use the quadratic formula. So when I do that, again, your A is with your squared term, your B is with your linear term, and your C is with your constant. So I'm just going to start plugging all of this in. And when we do this, I always start by finding what's ever under my radical first. So 11 squared minus 4 times 10 times negative 3. That is going to end up being addition because that negative times a negative gives you a positive right here. And under that radical, I get square root of 241. And then you should always try to simplify your radical. In this case, there is nothing that can be done to simplify the square root of 241, but you should always try. I'm going to show you an example of that on the next one. On this one, again, I try to keep my x squared positive, so I'm going to move both of these over. And I am going to, again, put it in order of descending exponent. This doesn't factor diamond. You can pull a 3 out, and when in doubt, that will make your life easier, just shrinking your numbers down. So I always recommend that, though that's not technically required. And again, if I tried to factor this, 2 times 3 is 6. Adding to 6 is impossible. So that's what tells me I have to quadratic formula. If you factored a number out, you can just kind of ignore it. It will not have any implications on your whole problem. And when I do this, I end up getting negative 6 plus or minus the square root of 12 all over 4. And this is a prime example of something you're going to keep going on. This 12 I can simplify. Square root of 12 is really 4 times 3. Square root of 4, that comes out there. It's going to give me a 2 root 3 all over 4. And what you have to look for is something that goes into all 3 terms. If it helps you, feel free to split this apart into 2 different fractions. You can split that denominator, or you can split the numerator as long as they both stay over 4, and simplify them individually if it makes sense. Regardless, what you should have, a 2 comes out of everything, so you get negative 3 plus or minus the square root of 3 over 2. Or again, if you had pulled it out, it would be negative 3 over 2 plus or minus square root of 3 over 2. Those are the exact same answer, and I'm good with you giving that to me either way. But there will be some quadratic formula problems in both 3A and 3B, so make sure to test those out and that you're confident. What we had a little more questions about, again, in looking at our pretest, was our quadratic form, or things specifically with fractional exponents. So we're going to talk about this in some more detail. Oh, before I forget, I apologize. The domain for both of these, since that is something we're doing this chapter, as we talked about on that overview, any polynomial is negative infinity to infinity. So both of these, you could get any x value as an answer, and so we're not surprised when we get the ones that we do. Okay. First off, to talk about the domain issue here before I forget it. We do have to remember that this is really a rational exponent, so that is a square root. So we have to follow our domain rules for our square root since it's more specific. It's going to be your limiting factor in this problem. So you have to remember that's really the square root of x, which means you need x to be greater than or equal to 0. So our only answers we expect to be between 0 and infinity. As for actually factoring this, 7 times negative 54 gives me negative 378. And I'm adding to negative 33. It's going to take me a second here. Let's see. Divided by 6. Nope. 9 and 42. So it's going to be negative 42 and positive 9. That actually works as that pair. When we do this, again, we replace the middle term. So it's going to be negative 42x to the 1/2 plus 9x to the 1/2 minus 54. And when I do this, from the first two terms, I can pull out a 7, and we always pull out the smaller exponent, which is the x to the 1/2. When you do that, what you get inside, technically, you're doing 7x, what was originally there, and you're dividing out 7x to the 1/2. Well, the 7's cancel, and then I can really just look at exponent rules. It's telling me to do 1 minus 1/2, since those are divided, and you get x to the 1/2. And when you divide it out of the second part, we're doing 42x to the 1/2 divided by 7x to the 1/2. Well, the x to the 1/2's cancel. 42 divided by 7 gives you negative 6. From the back part, I can just pull out a 9, and then this will be x to the 1/2 minus 6. When I rewrite this, 7x to the 1/2 plus 9 times x to the 1/2 minus 6 would be my factors. Again, I'm not sure if I mentioned it here, but we did talk about in the original unit. You are allowed to factor like this so long as your first exponent is twice as big as your second. So the reason this worked is because 1 is twice as big as 1/2. Now what we have is we have a problem that says 7, and I'm going to change this to a square root real quick. 7 times the square root of x plus 9 equals 0. And the square root of x minus 6 equals 0. This now looks like stuff we talked about in Unit 2. Back in Unit 3A, I didn't make you solve these because I didn't want it to be too overwhelming, but now that we're looking back and reviewing, it's a great time to practice. When we solve this, it would be square root of x equals negative 9 over 7. When I square both sides, I would get x equals 81 over 49. When I solve the second one, I would get square root of x equals 6, and so x is 36, but we do have to check. One note I will make to you, here, a square root of a number cannot be negative, so I immediately know this is going to go away. This one seems plausible, and so I'm going to check it, but I would just give you that reminder that if a To actually go about and check it again, I'm going to plug it back into my original problem. So I'm going to do the 7 times 81 over 49 minus 33 times 81 over 49 to the 1/2, and then minus 54. And I need to make sure that gives me 0. And then 7 times 36 minus 33 times 36 to the 1/2 minus 54. When I type this in, here I end up getting negative 84.857, if I did that correctly, equals 0, which is not true. And so this one does go away. Again, because this was negative, we kind of anticipate that that's going to be a problem, but we know for sure now. Doing the second one, I do get that 0 equals 0, so 36 is my one and only solution. Now, if we think back to how our exponents tell us how many answers we should get, it makes sense because my biggest exponent is a 1, and I expect 1 answer. One other thing that was not on your pretest, but I wanted to make sure to address, is our sum and difference of cubes factor pattern. Which looked like this. And so this is a sum and difference of cubes. Cube root of x cubed is just x. The cube root of 27 is 3. Because it is subtraction in my problem, I'm going to use the bottom sign across the board. And so it's going to give me x minus 3 times x squared plus 3x plus 9. Anytime you do this, the resulting trinomial you get should not be factorable. You will have to actually quadratic formula that, but you should get one of your answers here. And so one of my answers is 3. For the rest of my answers, because I do expect 3 based on the highest exponent being a 3, I'm going to quadratic formula. With your difference of cubes, often your quadratic formula will give you an imaginary solution, as once you get to this point of negative 27 under the radical, you will see that is okay. It's just most often the case. With that negative 27 under the radical, I can pull an I out. 27 has 9 that goes into it, which comes out as a 3, and then a 3 stays inside, all over 2. And so these would be my 3 answers. I have one real solution that would give me an actual x-intercept on a graph, and I have 2 imaginary solutions that I won't see on the graph, but we do when we're solving algebraically, we have to take into account and factor in. Last but not least was another type of quadratic form that we talked about. Again, what was important with quadratic form is your first exponent is twice as big as your second one, so that means I can factor using my x. So multiplying to negative 30 and adding to 13 would be 15 and negative 2. And then again, we're going to write this all the way out. Factor by grouping. From the front half, I can pull out 5x squared, and this will be x squared plus 3. From the back half, I can pull out a negative 2, and again, it's x squared plus 3. And then this turns into 2 more quadratic equations to solve, because I would have to do 5x squared minus 2 equals 0, and x squared plus 3 equals 0. But this is a perfect time for me to remind you that if you only have an x squared term and everything else is a constant, you don't have to quadratic formula. You can solve by square rooting. Now what that was, we isolate our x squared term. So I would add 2 and divide by 5. Or in this case, I would subtract 3. And then you square root both sides. Over here, first off, when you square root, it has to be plus or minus. That radical technically goes to the top and bottom, and we do have to rationalize, which is a big throwback, meaning you multiply by that denominator's radicand on top and bottom, because you don't want a radical in the denominator. And what happens, square root of 5 times square root of 5 is square root of 25, or just 5. On this other one, again, you have plus or minus. There was a negative under the radical, so it's an I, and then it's square root of 3. So those are my other 2 answers. I had highest exponent of 4, and I have 4 answers here, so it all checks